a bullet of lead just melts when stopped by an obstacle. So we have got some obstacle over here. Okay, a big obstacle, and what we are doing, we are firing a bullet. What is the mass of the bullet? Let's say the mass of the bullet is m grams, because here what we are finding, everything has been mentioned in grams. Okay, calories per gram. So what I am taking, mass of the bullet to be m grams. So how many kgs? Or m into 10 to the power of minus 3 kg. Now just take care, when we are talking about calorimetry or heat or thermodynamics, what is the SI unit? Most of the time certain data may not be mentioned in the SI unit, so you need to be very vigilant on that part. यहाँ पर देख रहे हो ना, स्पेसिफिक लेटेंट हीट ऑफ लेड किस में दे रखा है? स्पेसिफिक लेटेंट हीट दे रखा है कैलोरीज पर ग्राम में। तो मैंने बुलेट के मास को किस में ले लिया? m ग्राम। अगर ये m ग्राम है तो कितने केजीज होने वाला है? m into 10 to the power of minus 3 kgs. Now thermodynamics में तुम्हें ऑन एंड ऑफ यूनिट कन्वर्जन करना, यही इंपॉर्टेंट है। इस पूरे टॉपिक में एक जो कॉन्सेप्ट जहां पर बहुत बड़ा रोल प्ले करेगा वो है ऑन एंड ऑफ यूनिट conversion. So this is a particular bullet of mass m. It is fired for this obstacle. This bullet enters the obstacle and then comes to rest. And 25% of the heat produced is absorbed by the obstacle. So 25% of the heat that you are going to produce is going to get absorbed by the obstacle. Okay, 25% of the heat produced will be getting absorbed by the obstacle. That means how many percent of the heat is going to remain? So 75% of the heat produced, 75% of the heat produced will be retained by bullet, will be retained by bullet. So this information is going to be quite handy to us while solving this particular problem. 75% of the heat produced will be retained by the bullet. Now, we all know first law of thermodynamics says, what does the first law of thermodynamics says? That mechanical energy gets converted into heat. And the formula of mechanical energy and heat equivalence is W is equals to J times Q. What does W stand for? W stands for some mechanical work that you are supposed to do. This is the mechanical work, and if you just look in our previous discussion, mechanical work can be of two types. What are those two types of mechanical work that one can do? One is change in kinetic energy, another one is the change in potential energy, isn't it? So here when the bullet is fired, bullet goes, penetrates. What type of mechanical work is the bullet going to do? Change of kinetic energy. So let's try to find out the change in kinetic energy. What will be the change in kinetic energy? Initially the bullet was traveling with some velocity. Let's say the velocity of the bullet is v. So and its mass is m into 10 to the power of minus 3 kg. So what is the initial kinetic energy? Half m into 10 to the power of minus 3 into v square, where velocity is in meter per second. Remember, in everywhere in physics except for heat and calorimetry, always the data have to be substituted in SI unit. It is only in the first law of thermodynamics where you are having specific heat capacity given or latent heat given. Please check the data, how the data has been expressed. Whether the data has been expressed in the CGS format or whether the data has been expressed in the SI format. That is one thing you have to be very sure of. That is one thing that you should be careful while solving this particular type of problem. Now finally the bullets comes to rest, so the change will be this much amount of kinetic energy. Is this much clear to everyone? So this is the change in the kinetic energy. This is my equation 1. Substituting it over here, W is equals to change in kinetic energy. So half m into 10 to the power of minus 3 into v square is equals to J times Q. So the amount of heat energy produced when the bullet goes, hits the target, comes to rest. So this comes out to be half m into 10 to the power of minus 3 v square upon J. Remember what was J? J was the conversion factor and the value of J is 4.12. So when I am going to 4.18, sorry, not 4.18 or 4.2. So whenever I am going to substitute this in the final expression, I am going to make that conversion. Am I clear? Is that okay to everyone? This heat produced, whatsoever the heat has been produced, only 75% is going to be retained. 75% means how much? 3/4 of the heat produced. This is the heat produced. Heat produced. So out of this heat produced, only 75% of heat produced is retained. Retained by what? Is retained by the bullet? Yes or no? Now if you see 75% of the heat is retained, 75% in fraction means 3/4. अब ये fraction conversion तो percent means 1/100. So 75% means, so this is the heat produced, heat retained. I am just interested in finding out heat retained by the bullet. So what is the heat retained by the bullet? That is 3/4 of heat produced. This is the heat produced. So this is going to be equal to 3/4 times of 1/2 m into 10 to the power of minus 3 v square by J. Is this clear? तो ये जितनी भी हीट प्रोड्यूस्ड हुई है उससे क्या हो रहा, बुलेट का टेम्परेचर राइज करता है, क्योंकि बुलेट देखो इनिशियली कितने टेम्परेचर पे, बुलेट इज इनिशियली एट 27 डिग्री सेंटीग्रेड, और इसकी वजह से बुलेट क्या करता है, फाइनली मेल्ट करता है. ठीक है ना? क्या क्वेश्चन कह रहा है, a bullet of lead just melts. तो जो भी हीट प्रोड्यूस हो रही है वो हीट प्रोड्यूस कहां जा रही है, पहला उसका टेम्परेचर को राइज करेगी, क्योंकि बुलेट का मेल्टिंग पॉइंट यहाँ पे अगर तुम देखोगे तो क्या दे रखा डेटा में, 327 डिग्री सेंटीग्रेड. तो जो कुछ भी हीट है किसके पास, बुलेट को जो हीट मिल रही है वो दो काम कर रही है. वो क्या करती है, बुलेट का टेम्परेचर 27 से पहले लेके जाती है कहां तक, 327 डिग्री सेंटीग्रेड तक. एंड देयर आफ्टर द प्रोसेस ऑफ मेल्टिंग स्टार्ट्स. तो कैलोरीमेट्री में तुमने पूरा प्रोसेस पढ़ा था. सो whatsoever the amount of heat has been produced, उसका 3/4 जितना हीट बुलेट ने रिटेन किया. अब इस हीट रिटेन by the bullet will be utilized for what, will be utilized for melting the bullet. Yes or no? Now this melting of the bullet will take place in 2 steps. What are those 2 steps? Step 1 is to raise the temperature, that is from 27 degree centigrade you have to go up to 327 degree centigrade. Is that clear? That is the melting point of the bullet, and the heat required for this will be mc delta theta. And thereafter step 2, since the bullet has to melt, what has to happen? Change in state. The second step will be the change in the state of the bullet, that is Q2. If this is Q1, this is Q2, then Q2 must be equals to m into L. Clear? Now see, when you are referring to the data, you will find over here the specific heat capacity of the lead has been mentioned at calories per gram, and the latent heat is also mentioned in grams. So look, here the data is being mentioned in grams, so I am not going to convert mass of the bullet in kgs. I am going to take the mass of the bullet in grams, and will find how much heat is required to melt the bullet. Now remember, always keep that fact into your mind. While melting the bullet, there are 2 steps that are involved. What are those 2 steps? One is to cause the rise in temperature, cause the rise of the temperature to take place, and the second one is, so the heat required to melt the bullet. So I'm just finding out the heat required to melt the bullet. Heat required to melt the bullet. And that is Q1 plus Q2. What is Q1? MC delta theta. And what is Q2? M times L. Mass of the bullet still remain M. What is the specific heat given for the bullet? The specific heat given is 0. See, I am putting M in grams. Specific heat is 0.03 calories per gram per degree Celsius. I am writing down the units for you. Just be careful. All game plan over here is going to be about the unit. Okay. You are not able to solve this problem because of not being able to convert the unit properly. That is where the whole problem lies. And how much is the rise in temperature? From 27 you are reaching to 327. So the rise in temperature will be 327 minus 27. Is that clear? That is eventually 300. Plus what is M? Again M is M in grams, and what is the latent heat? That is 6 calories per gram. See, this gram and this gram goes off. Solving this, okay, if I start solving this, you will find this G and this G cancels out, and this becomes M into 0.03 into 300 plus 6M calories. Okay, rest of the things are cancelled. And if you notice over here, these two and this decimal point goes, 3 3s are 9M plus 6M. So heat required to melt the bullet is 15M. So this is the heat required to melt the bullet. Am I clear with this? Now, this heat required to melt the bullet is going to be equal to the heat that is already retained by the bullet while doing that mechanical work. So how much was the heat retained by the bullet? Just look up. You will find the heat retained by the bullet was 3/4 half M. So these two things must be equal. So what I am doing, I am just putting this. Heat required to melt the bullet must be equal to the heat retained by the bullet. Heat required to melt the bullet must be equal to heat retained by the bullet. How much is the heat required to melt? That is 15M. How much is the heat retained? That is 3/4. किसका 3/4 था? Half M into 10 to the power of -3, because in mechanics we are using the SI unit. It is not thermodynamics where we have to look at the specific heat capacities unit. So this is going to be into this part, into V square divided by J. These two things must be equal. Let's simplify this. M goes with M. So we get an expression for V square. V square is equals to 15 into 4 upon 3 into 2 into J upon 10 की power -3. 3 5s are 15. V square is equals to 5 into 4 into 10 की power 3 into J, that is 4.2. Please solve it out. Solving goes out to be 1.68 into 10 to the power of 5. Therefore, V will come out to be 4.099 into 10 to the power of 2, or V is equals to 410 meter per second. So that should be your answer.